So in the previous video, we have learned that all matter is made up of extremely small particles called atoms or molecules, and that these particles are constantly moving. Now recall, we have learned we have not seen these particles, nor can we see them with a high power microscope. So how do we know they are there? The answer is results of experiments. So now we'll see those experiments which will prove to us matter is indeed made up of tiny particles which are moving. So the first type of experiment which we see is dissolving a solid in a liquid. So here we'll take the example of potassium permanganate plus water. So this is what potassium permanganate looks like. It is basically a purple colored substance. And this over here is water. So what we do in this experiment is we take a small amount of potassium permanganate and we place it in water. Right. So initially only this part is purple. Now don't touch the beaker, don't stir it, just leave it for some time. After some time you'll notice the entire water becomes purple. So let's understand this with the help of a figure. So see, initially we placed potassium permanganate crystals over here. Water is clear, only purple colored over here. After some time, this parts of the water becomes purple and then the entire water becomes purple. Is this clear? So now the question is, what is happening over here? So let's first read this much and then I'll explain how this happened. Potassium permanganate is a purple colored solid substance and water is a colorless liquid. So we'll first study the dissolving of potassium permanganate in water. When a crystal of potassium permanganate is placed in a beaker of water, the water slowly turns purple on its own, even without stirring. So now scientists began to think that we just placed a purple colored crystal over here. How did the entire water become purple? This is where the theory comes into picture. So see guys, scientists said that water and potassium permanganate both are made up of large number of tiny particles. Is this clear? So even though I put a small amount of potassium permanganate, it is actually made up of billions and trillions of particles. That is how small these particles are. Now these particles are constantly moving. So though I've put only potassium permanganate here, these particles are moving and the water particles are moving. So they will collide with each other. Because of the collision, they start moving here and there. So see, the potassium permanganate crystals separate out and they're moving throughout the beaker. Wherever the purple crystal glows, the water becomes purple. Is this clear? So because of this, the entire water becomes purple on its own. Hence two things. One, matter is made up of tiny particles, and number two, it's constantly moving. See, if the particles were not moving, the particles would not have gone from here to here. That is, the whole water would not have been purple. Only this much would have been purple. But because the entire water became purple, that means this particle went from here all around. How did it go on its own? We didn't stir it, right? That means they're moving on their own. So this experiment confirms matter is made up of tiny particles which are constantly moving. Is this clear? I hope this much is clear. Let's read about it. So see guys, the spreading of purple color of potassium permanganate in the whole water of beaker can be explained as follows. Both potassium permanganate crystal and water are made up of tiny particles. The particles of potassium permanganate are purple colored, whereas the particles of water are colorless. When the potassium permanganate crystal is put in water, its particles basically separate from one another. These purple colored particles of potassium permanganate spread throughout the water, making the entire water purple. Is this clear? Actually, on dissolving, the particles of potassium permanganate get into the spaces of the particles of water. See, they're basically between the particles of water, and that is how the entire water becomes purple. Is this clear? So I hope this much is clear. Let's read ahead. So see guys, this is an actual picture of water and this is how the purple color is going to spread. So see, in this experiment, the particles of potassium permanganate and those of water mix on their own without any external stirring. We're not stirring it, it's mixing on its own. Since the particles of potassium permanganate and particles of water spread into each other and mix up on their own, it is concluded they are moving or they are in motion. Is this clear? If the particles were not moving, the color could not spread throughout the beaker on its own, right? This movement of different particles among each other on their own, so they become mixed uniformly, is called diffusion. So recall I used the word diffusion, right? This is diffusion. What is diffusion? Movement of different particles, water and potassium permanganate, on their own to form a mixture is known as diffusion. Is this clear? So I hope the experiment of potassium permanganate and water is clear. Let me take another example guys. Dissolving sugar in water. So what we do guys is we basically take a beaker of water, add sugar particles to it and then we stir it. The reason we are stirring it for making sugar dissolve faster. Now once you stir it, you will notice that the sugar disappears. Where is the sugar gone? If you drink this water, it is tasting sweet. That means sugar is there. But can you see the sugar particles? No. So where has the sugar particle gone? Again, the same concept, guys. So what we say is that the sugar particles and water particles are basically mixing with each other. So what happens is the sugar particles actually occupy space between the water particles. So whatever water particles are there, the sugar particle will go between that, hence we cannot see it. But because it is there, hence the water tastes sweet. So again, water and sugar both made up of large number of tiny particles and they're constantly moving. So let's read about it. When sugar is added to water and stirred, it dissolves quickly. The sugar seems to disappear. What happens to the sugar when it dissolves? Where does the sugar go? We cannot see it. Both sugar and water are made up of very small particles. These particles are too small to see even under a microscope. Is this clear? When sugar dissolves, tiny sugar particles break off from each solid sugar granules. Now you can see the sugar granule, right guys? To you it appears very small. Actually, even that small sugar granule is made up of trillions of particles. That is how small these particles are. So the moment that crystal of sugar goes in water, it breaks up into those trillion particles. And those trillion particles basically move throughout the water and occupy the spaces between the water. That's how you cannot see it. These sugar particles go into the spaces between the particles of water and mix with them. So the sugar solution will taste sweet even though we cannot see the sugar in it. So where have the sugar particles gone? They have basically taken the spaces between the water particles. That is why we cannot see them. Please note that in this experiment, we have dissolved sugar in water by stirring. So you're probably wondering, we cheated this time, we stirred it. Doesn't matter guys, that is only to make it dissolve faster. Is it clear? This has been done just to dissolve the sugar quickly. Is it clear? Even if we don't stir, sugar will dissolve in water, but quite slowly. Is this clear? So this is the category of experiments dissolving a solid in a liquid. So potassium permanganate plus water, the entire water becoming purple, and here dissolving sugar in water, the sugar particles disappear. Both these experiments prove to us all matter is made up of very small particles which we cannot see, and these particles are continuously moving. That is why the entire water became purple over there, and here the sugar has disappeared. Is it clear? So I hope these experiments and the results are clear.